Hi all, this is Mr. Yeager, Physical Science. We're continuing our chemical reaction unit and we're looking at the types of reactions. We're going to look at types of reactions and then I'm very quickly going to talk about the law of conservation of mass a little bit more, like we talked about when we were balancing reactions. We balance reactions because we want to have the law of conservation of mass happen. So what if we actually get some numbers involved with that? So we'll look at that at the end. But first off, there are 4 types of chemical reactions out there. So after you balance a chemical reaction, you may be asked, what type of reaction is this? So there's 4 types. The first type, let's get that out of the way. The first type is going to be synthesis. Okay, the first type is synthesis. The way I'm going to show each of these reactions is using the letters A and B or X and Y and stuff like that, where these can be any elements you want, all right? And then this is what's happening to those elements. So what I have in synthesis is I basically have 2 elements, okay? 2 elements that are separate as reactants that then combine to form a larger product, all right? So the most classic way this is shown is with 2 elements, but it could be technically, you know, a compound, and then this becomes basically some sort of conglomeration, a group of the compound and element all joining together. But synthesis is where basically you put those elements together. You create a larger product in the end. Okay? So a couple examples that I have are right down here, so you can see these. All right. So what you have is you sit here and be like, oh, okay. So calcium is one element, and a lot of times the way I show this is I tell my students to write, like, call calcium A, and we're going to call oxygen B. Yes, there are 2 of them. We're not worried about that, but there's only 1 element, okay? And then all we got on the product side is where I'm putting the 2 together, okay? So now instead of A being separate from B, now A and B are combined into a compound. And then we would try to balance it, okay? Or do that at the end, do that at the beginning. If I want to balance it, 1 Ca, 1 Ca, we're all good. 2 O's, 1 O, so I need to put a 2. So now I have 2 Ca, so I come back and put a 2 right there. Okay? But these are all synthesis reactions. Again, A plus B producing AB. A plus B producing AB. Okay? So the elements, the reactants are combining to form a single product. And if I want to keep balancing, Na, 1, 1, 2 Cls, 2 C, or 1 Cl, sorry, 2. And then I need to put back and do 2 Nas. How about for this bottom one? 1 Al, 2 Al, so 2 Als, 1 S, 3 S's, 3 S's. Okay? So that's a synthesis reaction. 2 things coming together to form 1. Decomposition. In decomposition, it's essentially the opposite of synthesis. This is where you start off now where you have a compound. Those elements are together and then they split up. Okay? They break into smaller compounds or elements. They come in, they are smaller than where they started. It's almost like a fission reaction. We're not going to call it fission. Fission is a nuclear reaction. This is chemical. During a chemical reaction, we say it's decomposition. It's splitting apart into its elements. So here's examples of decompositions. Okay, you can see right here I have iron 3 oxide, splitting up into the elements, iron and oxygen. If I want to try to balance this one, I might be going 2 Fe, 1 Fe, so 2, 3 oxygens, 2 oxygens. Remember, that's a very common situation, 2 and 3, raise them to 6. So I need to put a 2 out in front of Fe2O3, a 3 in front of O2. But now I have 4, 2 times 2 is 4 irons. So there we go. On the bottom, another decomposition. AB producing A plus B. They are separate. In this particular equation, everything's already balanced. 1 Mg, 1 Mg, 2 Cl, 2 Cl. Okay? So again, we don't always, that's something important to recognize. It's already balanced. Single replacement. All right, single replacement, what I have is basically I do now have a compound and then I'm reacting it with just a single element. So in this case, what I'm referring to as AX is this is some compound. And what's going to happen is the element's going to come in and kick one of those elements out. All right? So one element comes in and kicks the other one out, and you can see the result on the other side. So B came in and kicked A out, and now it's BX plus A. Single replacement. All right? It's where somebody comes in, takes that one thing of yours, and now you're left with nothing. All right? The one thing we should kind of pay attention to with these, if the element is a metal will replace a metal. A non-metal, I'm going to just write NM, a non-metal replaces non-metal. Okay? So you got to pay attention. It's not, if this is a non-metal, it's not going to come in and replace the metal. Okay? It's not going to do that. So metal replaces metal, non-metal replaces non-metal. Sorry. Let's get this back on. So here's examples again. All right. So let's show this one a little bit more. AX plus B. B is a metal, lithium's a metal, so it's going to go in and take out A. And so all of a sudden now I have BX plus A. And this one's actually already balanced. 1 Na, 1 Na, 1 Cl, 1 Cl, 1 Li, 1 Li. All right. Right here, I have a non-metal. So the non-metal is going to come in and replace the other non-metal. It's going to kick it out. So the metal stays the same. So then over on this side, you can see now it's MgCl2 plus I2. Again, that's all balanced. In the last one, I'm back to a metal again. So the metal is going to come in, replace Al, and kick it on out, forming NaCl plus Al. This one I need to balance. So I have 2 Als, so I'm going to put 2 Als right there. I have 3 Cls, so I'm going to put 3 Cls right here, 3 NaCls, and now I have 3 Nas to finish up. So single replacement, basically the way we always kind of do it in class is somebody comes in and steals your boyfriend or girlfriend. Okay, that's basically what's going on there. The last type of reaction is a double replacement. This is where basically they switch partners. So you either think that A replaces B, or A and B switch, or X and Y switch. Don't be thinking both switch, because then everything's going to go back to the way it was. So A is with X, but over on the other side, A is with Y. B is with Y on the reactant side, but now it's B with X on the product side. So double replacement is where basically you basically switch dance partners. Okay. So examples here. All right. We got AX plus BY, and then on the other side, we got AY plus BX. So they are switching there. The biggest thing with these, usually, if people actually have to write them out, is remember you always have to write metal, non-metal. I will see people write this as Cl2Ca, and they haven't done that all unit, and then all of a sudden do it right now. So make sure you don't make that mistake. This one we do have to balance. 1 Li, 2 Li. So 2 LiCl. Now I have 2 Cls, 2 Cls. I'm good. 1 Ca, 1 Ca, 1 O, 1 O. That's all I had to do. Another double replacement. Al and Na switch spots. Okay, so Al's with fluorine, or sorry, Na's with fluorine and Al's with oxygen. I do have to balance. 1 Al, 2 Al, so I'll put a 2 right there. I now have 6 fluorines. Over here I only have 1, so that's 6. I have 2 NAs and 6 NAs, so I need to multiply this by 3. 3 O's, 3 O's, look at that. Everything comes out nicely. So, it's very common that you might have to identify what type of reaction it is. Just synthesis, elements come together. Decomposition, compound splits apart. Single replacement, one element comes in and replaces. Double replacement, there's a double switch. Basically two compounds, and we switch the first or second elements. Either way you want to look at it. So let's finish up with this, law of conservation of mass. This would be the last part that I throw into my chemical reaction unit. Basically, all you need to know about this, and it was mentioned back in chemical reactions as well in the PowerPoint on that, my lecture on that one, the video. Total mass of reactants has to equal the total mass of products. All right. Again, when we actually do it, this is the idea of like efficiency and things like that. Sometimes the reactions aren't completely efficient, so we don't get everything we want. but we should still have this total mass be the same, even though those atoms are rearranging and forming new products that weigh differently. Okay? It just depends on how much of it you have. So a problem that you might run into would look something like this. So I have Li plus Cl2 yields LiCl. So what type of reaction is this? This would be one element plus one element forming a compound. So what would that be? This is a synthesis reaction. All right, so let's check this out. I have two problems here. If 10 grams of Li reacts with 20 grams of Cl2, how much LiCl should form? So this is sort of why we have this plus sign here. What I can do is I can say I have 10 grams of Li, I have 20 grams of Cl2. Well, these things should combine, and my total mass of reactants has to equal. The arrow can turn into an equal sign. The total mass of reactants has to equal the total mass of products, so 10 plus 20 is 30 grams. There's really not too much to these. All right? In a real lab situation, most likely you'd be lucky if you're forming maybe like 12 grams of it, probably even less. Now, are we saying that conservation is lost? No, it turns out mass can change into energy, and that's where possibly some of the mass is lost. But the ideal when I do this reaction is I'm looking to try to get 30 grams. Okay, I should hopefully have 30 grams left. I forgot to do one thing. I should balance this. 1 Li, 2 Cl, 1 Cl, so 2. Okay, so that's how we're doing the conservation of mass. It's just total mass of reactants equals total mass of products. What's the one variation? Well, what if I give you something about the product instead? If 50 grams of LiCl is formed, so I know that there's 50 grams of LiCl, it still has to equal the total mass of products, or sorry, reactants. It says 15 grams of lithium is reacting, so 15 plus what is 50? This would be 35 grams. Okay, 35 grams. And that's it. All right, thank you.